Welcome to the third class of chemistry in biological process. In the last class, we studied what enzyme is and what is its classification. And in this class, we are dealing with the chemical nature of enzymes. And first coming to the physical state, that is, enzymes are generally colorless solids. But there are some exceptions are there and some are colored blue, green, gray or yellow. Generally these enzymes are colorless, but some enzymes are colored. That is, they are exhibiting blue, green, gray or yellow color. This is a physical state of enzyme. And the second one is a cofactor or activator. You all know that proteins, the enzymes are proteins, and besides proteins, there are some non-protein part also in enzymes, and that non-protein part is termed as cofactor or activator. And these cofactors or activators are responsible for the catalytic activity of the enzyme. The main function of the enzyme is catalytic activity, and this catalytic activity is controlled by the non-protein part of this enzyme termed as cofactor or activator. And the second term is coenzyme. Actually, this coenzyme is a cofactor itself, but this can be separated by dialysis. That is, I'm repeating, this cofactor or activator is a non-protein part of the enzyme which is responsible for the catalytic activity. And coenzyme, that is, coenzyme is also a cofactor, but this can be separated by dialysis. And the next term is prosthetic group. And this prosthetic group is also a cofactor. That is, if a cofactor remains bound to an enzyme, it is called as prosthetic group. That is, in some enzymes, this cofactor will remain bound to enzyme. And in that case, this cofactor is termed as prosthetic group. And the next one is metalloenzyme. That is, the cofactor is an inorganic ion. Inorganic ion means that metals, etc. And if the cofactor is a metal, that is an inorganic ion, and it is bound to an enzyme, and it is termed as metalloenzyme. That is, we saw three types of cofactors. First one is cofactor or activator, that is a non-protein part of the enzyme. The next one is a coenzyme, that is a cofactor which can be separated by dialysis. And the next one is if a cofactor remains bound to an enzyme, it is called a prosthetic group. And if the cofactor is an inorganic ion or a metal, it is called metalloenzyme. And the next term is haloenzyme. That is a cofactor enzyme complexes. That is, haloenzyme is a no, it's not a cofactor, it's a complex. That is a cofactor enzyme complex. That together, cofactor and enzyme together, that is termed as haloenzyme. And the apoenzyme, next one is apoenzyme. Apoenzyme is the protein part left after the removal of coenzyme. That is, in this slide, we saw three terms, three main terms, that is cofactors and cofactors, different types of cofactors, that is coenzyme, prosthetic group, and metalloenzyme. And the second one is haloenzyme, that is the cofactor enzyme complex. And the next one is the apoenzyme, that is the protein part left after the removal of coenzyme is apoenzyme. Next is the protein nature of enzymes. You all know that enzymes are proteins. So, these enzymes are proteins with high molecular weight. You have heard about what molecular weight is. For all chemical substances, there is a mass. That mass is termed as molecular weight, that weight of that molecule, that is molecular weight. These enzymes are proteins with high molecular weight. This molecular weight of these enzymes are very high. For example, pepsin. Pepsin is an enzyme that its molecular weight is 35,000. And another enzyme, urease, and molecular weight of urease is 4,80,000. That means it has got high molecular weight. Next property is that, like proteins, enzymes are stable in concentrated solution. You heard about concentrated solution and dilute solution. If the solute number of solute particle is greater, we said that it is a concentrated solution. And if the number of particles, that is solute particle, is lower, we termed as it is dilute solution. So like protein, enzymes are stable in concentrated solution. And also isoelectric points of several enzymes are known. Isoelectric point is a pH. In the particular pH, this enzymes, there is no net charge. That is isoelectric point. So in isoelectric points of several enzymes are known, and at this pH, these are least soluble and can be precipitated by alcohol. So the importance of isoelectric point is that it is a neutral point, and also at this pH, these enzymes are least soluble and it can be easily precipitated by alcohols. These are the protein nature of the enzymes. And also next point, they undergo denaturation on increasing temperature. Denaturation means that losing that protein part, the protein nature and protein habit of that enzyme. So when increasing temperature, this enzyme undergoes denaturation. That is that texture of that protein may change, or texture of that enzyme may change. That is denaturation. So they undergo denaturation on increasing temperature. Generally, these enzymes are soluble to some extent in water, glycerol, and dilute alcohol. They are not completely soluble, but to some extent they are soluble in water, glycerol, and dilute alcohol. And also, it can be precipitated by precipitating agents like ammonium sulfate, chloroacetic acid, concentrated alcohol, etc. And also, these proteins has got colloidal nature. That means enzymes has got colloidal nature. And finally, these enzymes can act as catalyst in most of the chemical reaction. That is a very important property of that enzyme. That enzyme act as catalyst in most of the chemical reaction. In proteins also, this is because of the protein nature of the enzymes. These are the protein nature of enzymes. And next one is the factors affecting enzyme action. It is a very important topic. That is the factors affecting enzyme action. There are several factors affect the enzyme action, and the first one is the concentration of the substrate. You know that what substrate is? Enzyme and substrate. That is in the what the material in which the enzyme act. That is known as substrate. If that is the first point is the concentration of the substrate. That is, enzyme action is best on dilute solution of substrate. So enzymes prefer substrate to be dilute. So enzymes action is best on dilute solution of substrate. And second point is the concentration of enzyme. First point we have seen that's the concentration of the substrate, and the second point is the concentration of enzymes. That is, the speed of reaction is proportional to concentration of enzymes. That means enzyme action will increase with the increase in the concentration of enzymes. But in the last case, we saw that the concentration of a substrate, that is enzyme action, is best in dilute solution of substrate. That means that is inversely proportional. But in the case of concentration of enzymes, if the enzyme's concentration increases, that reaction also increases. These are the 2 points. And the third point is the temperature. For enzymes are best in the range of 40 to 50 degrees Celsius. So in the range of 40 to 50 degrees Celsius, enzyme action will be higher and will be good. That is the importance of temperature. And also the next point is pH. For each enzyme, there is an optimum pH. And these are the 4 factors affecting enzyme action. 2 more are there. And next one is activators. That is, some metals like sodium ion, magnesium ion, etc., when removed from protein part of enzyme, it loses their activity. That means it loses their enzyme activity when these metals like sodium, magnesium, etc., are removed from the protein part of the enzyme. So these metals are called activators. That means when we are removing these particular activators from this enzyme, it loses its activity. That is, so we term it as activators. And the next point is inhibitors. These are just reverse of activators. That means these are substances when added to enzymes decreases the rate of reaction. That are inhibitors are substances when added to enzymes decreases the rate of reaction. That is just opposite to activators. That means when activators are removed, this enzyme loses its activity. But when if inhibitors are present, it loses its activity. That is, activators and inhibitors are just opposites. So these are the factors affecting enzyme action. The first one is the concentration of the substrate. That is the concentration of substrate. Enzyme action is best in dilute solution. And the second one is the concentration of enzyme. That is inversely proportional. That means the concentration of enzymes increases, speed of reaction. That is proportional. Speed of reaction is proportional to concentration of enzymes. That concentration of substrate and enzyme action are inversely proportional. And the third point is temperature. That is enzymes are best in the range of 40 to 50 degree, and for optimum pH is needed for each enzyme. And there are two more factors, that is activators and inhibitors. And the next one is the specificity of enzyme action. These enzymes are highly specific in their action. That means for each enzyme, it has got a particular role. There are three types of specificity, that is reaction specific, substrate specific, and stereo specific. First of all, we can see what is reaction specific. That is reaction specific means this enzymes catalyze particular reaction. That means these enzymes only catalyze that particular reaction. For example, esterase. Esterase is an enzyme. It hydrolyzes only esters, not any other compounds. That is reaction specific. That is enzymes catalyze only that particular reaction. So this esterase is an enzyme which catalyze only that particular reaction, that hydrolysis of esters. That is reaction specific. And the next one is substrate specific. Substrate specific means some enzymes are specific for particular compound, not for particular reaction, but they are specific for particular compound. For example, urease is an enzyme. That urease only hydrolyzes urea, not any other compound. It only hydrolyzes urea. That is substrate specific. And the third one is stereospecific. Stereospecific means enzymes speed up the reaction for only one stereoisomer. There are stereoisomer means actually it is a type of isomer. Stereoisomer is a type of isomer. That means it has same contents formula but different structural arrangement. That is stereoisomer. For example, this glucose has got plus isomer, minus isomer, like that. For in this case, we are demonstrating this maltase. This maltase hydrolyzes only alpha glycosides. Actually, there are two types of glycosides are there, alpha glycosides and beta glycosides. But maltase, enzyme maltase hydrolyzes only alpha glycosides. So it is termed as stereo specific. Therefore, specificity of enzyme action. Enzymes are highly specific in their action, and there are three types of specificity: reaction specific, substrate specific, and stereo specific. Reaction specific means that enzyme catalyze particular reaction. That is esterase hydrolyze only esters. That is hydrolysis of esters only speed up by esterase, enzyme esterase. The next one is substrate specific. That means some enzymes are specific for particular compound. The third one is stereo specific. That is enzymes speed up the reaction for only one particular stereoisomerism. These are the specificity of enzyme action. And the last topic is the mechanism of enzyme action. How this enzyme act on different substrate. What is the mechanism of this enzyme action? This is a very simple. It has got three steps. And the first step is enzyme plus substrate. That means enzyme combined with substrate to give an enzyme substrate complex. That is the first step. That is enzyme combined with substrate to give enzyme substrate complex. This enzyme substrate complex is a single complex. And the second step, this enzyme substrate complex. Here we can see a reversible arrow. So this enzyme substrate complex can be changed to enzyme product complex, and also this can be reversible. Enzyme product complex can again change to enzyme substrate complex. So the second step, enzyme substrate complex can be converted to enzyme product complex. And in the third step is again a reversible reaction. Enzyme product complex can be changed to enzymes and products. That means it dissociate into enzymes and products. So first we start with enzyme, and here it end with enzyme. Substrate may get changed to product. That is, again I am repeating, in the first step, enzyme and substrate, they combine to form an enzyme substrate complex, and in the second step this enzyme substrate complex reversibly converted to enzyme product complex, and the third step, this enzyme product complex get dissociated to enzyme and product. So there is no change in the enzyme, but the substrate is changed to product. That is the mechanism of enzyme action. Thank you.